Okay, so now let's do another example. So now I want to find the derivative function for my function 1 over x. And so the first thing you want to do is you want to write down the definition of the derivative. So the definition says that the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x, and this is all over h. Okay, so now we need to figure out what our f of x plus h is because we already know what our f of x is. And so from this step to the next, we're just going to plug in f of x plus h and we're going to plug in f of x. But just to note to you what f of x plus h is, this is just equal to 1 over x plus h. Okay, because again, the function tells me that I take whatever my input is and I do 1 over my input. So here when I do f of x plus h, I just have 1 over x plus h. And so the other way you might have heard of it is wherever you see x, you want to replace it with x plus h from the original function. So here I'm going to now just plug in, and so I get this is the limit as h approaches 0 of 1 over x plus h minus 1 over x, and then all over h. Okay, so from here I just plugged in f of x and f of x plus h. Okay, so now this is the part where it gets scary, right? Because now we need to simplify these fractions. Because what happens when I plug in 0 for h? I get 1 over x minus 1 over x in the numerator, which gives me 0. And then in the denominator I get 0. So unfortunately I get this 0 over 0 case. And so this indicates to us that we need to combine these fractions in the numerator. And so I want to just recall that my LCD, or my least common denominator, between these denominators is x times x plus h. Okay, so I need to multiply both fractions by whatever's missing. So in the first fraction, 1 over x plus h, I'm missing an x. So I need to multiply top and bottom by x. And then same thing with 1 over x. I'm missing an x plus h, so I need to multiply top and bottom by x plus h. So here I get that this is equal to the limit as h approaches 0 of 1 over x plus h times x over x minus 1 over x, and then times x plus h over x plus h, and then divided by h. Okay, so whenever I say you need to multiply by what's missing, you need to make sure that you multiply top and bottom by the same quantity. Okay, so here I have that this is equal to, and now multiplying across, I get this is the limit as h approaches 0 of x over x times x plus h minus x plus h over x times x plus h, and then this is all over h. Okay, so now I notice that I have a common denominator between these two fractions here in the numerator. So to combine these fractions, what I need to do is just subtract the numerators, and then my denominator stays the same. Okay, and so you might have noticed here that I put parentheses around the x plus h, okay, because I want to subtract the entire quantity, all right? So if you forget that parentheses around the x plus h, you will get the wrong answer, because you'll have x minus x plus h instead of x minus h, all right? And so you want to make sure that you have parentheses around there. Okay, and so now when I distribute this minus, I get that this is the limit as h approaches 0 of x minus h all over x times x plus h, and then this is all over h. So now I'm going to simplify the numerator, so I get that the x minus x is just 0, so I'm left with negative h in the numerator over x times x plus h, and then that's all divided by h. And so now we can rewrite this as h over 1, all right, because h divided by 1 is still just h. And the reason why I'm doing that is because now what I want to do to figure out what this fraction is divided by this fraction is I need to flip and multiply by the reciprocal. And so this is going to be equal to the limit as h approaches 0 of negative h over x times x plus h times 1 over h. And so now these h's cancel. And so what I'm left with is the limit as h approaches 0 of negative 1 over x times x plus h. And so now at this stage, I want to plug in 0 for h. And so I get that this is negative 1 over x times x plus 0. And so what I'm left with is this is negative 1 over x times x, which is equal to negative 1 over x squared. Okay, and so what I did here is I plugged in 0 for h. Okay, and so you want to make sure, because I'm considering the limit as h approaches 0. Alright, so when I'm considering the limit as h approaches 0, that's telling me that when I go to plug in, I don't want to plug in for x, I want to plug in for h. And so overall, we say that the derivative function is equal to negative 1 over x squared.